Okay, good afternoon, everyone. Thanks for coming to the breakout session on responsible AI in the generative era. My name is Michael Kearns, and I'm an Amazon scholar, which means I divide my time between AWS AI ML and the computer science faculty at the University of Pennsylvania. At AWS, along with my good friend and colleague Peter Hallinan over here to my right, I'm very involved in all of our responsible AI efforts within AWS from both the technical end, enforcing various responsible AI dimensions that we care about, as well as thinking about things from the policy, legal, and regulatory perspectives and everything in between. And so the plan of record today is that I'm going to take a little bit of time at the beginning to first of all just talk about some of the science behind responsible AI these days, and especially the challenges to that science that are emerging in the generative AI era. And then Peter will take over after a little while and talk about how we kind of turn that underlying science into the practice of responsible AI in AWS AI ML products and services. And hopefully we will leave a healthy amount of time for Q&A towards the end. So I don't think I need to say too much about generative AI to any audience these days. I've been in this field for a very long time, and I sort of miss the days when my non-work friends didn't care about what I did instead of having to talk about generative AI at every dinner party. But this is just a little demo sort of showing you the type of thing that goes on behind the scenes in something like a large language model, where there's some initial prompt or context, as we might call it, and then the underlying model is computing what the probability distribution over the next word is, given the context so far. And then, of course, the sequence is one longer, and so you can apply the same process to the next token or word, et cetera. And there's great power in this. First of all, it's kind of scientifically incredible that just by solving this apparently myopic problem of next word distribution prediction, you get so many things for free, like syntax, semantics, compelling, coherent text in a style of your own choosing. And also because of the randomization involved, just because you're not always picking the most likely next word, but you're actually drawing from the underlying distribution, you get variation in the output. So of course the same prompt will generate completely different output the next time. And so this is an incredibly powerful technology that's become part of popular culture and society at large these days. And there are already a very, very large number of existing and rapidly emerging use cases for generative AI. It includes things like writing tools or aids to check your grammar, your spelling, your style, or the like, or to suggest alternative phrasings of a particular sentence. Productivity tools like using a large language model to summarize the transcript of a meeting and extract the action items from it, using it as an aid in creative content. Of course, many people know that generative AI can be used for actual code generation. And so the universe of people that might be able to participate in software development and similar processes is greatly increased by this. And so the excitement around generative AI is obviously understandable and well justified. And it brings great promise in new innovation and new products and productivity for us more generally as a workforce. But it also presents some new risks and challenges. And this is the kind of thing that Peter and I think about at AWS and try to address to the extent that we can, using a mixture of the underlying science and other sorts of procedures and policies around just the general AI ML workflow that we engage in. If I had to sort of say what is the one thing that distinguishes generative AI from all of the AI and ML that came before it up until a few years ago, it's the open-endedness of the output. It's the open-endedness both of the input or the prompt or the context, and the fact that instead of making point predictions about a particular input, like here's a digital image, is there a cat in this image, yes or no, you're just making some binary classification or prediction. Here you're actually generating free-form open-ended content. And of course that generality is part of the great power compared to traditional AI models. But as we'll see, it's also the source of some of the challenges that come up in curbing behaviors that are undesirable in certain contexts. And so what I want to do is spend a few minutes talking about the science of responsible AI in the pre-generative era, or what I like to sometimes call the before times. And the running example I'm going to use is, say, from consumer finance. You have historical loan applications that you actually granted loans to, so you know the outcome of that loan. And so you know whether it was repaid or defaulted. And a natural thing to want to do with such data is to build a predictive model on that data, that when you train on that data and then you hope that it generalizes well out of samples, so given a new loan application that you've never seen before, you'll make an accurate classification. And this is what I would call a very, very targeted problem. You know what problem you want to solve. You want to give loans to creditworthy individuals and not to the ones who might default. And you're making these very, very narrow predictions. You're just outputting yes or no, 0 or 1, okay? And so, what are the kinds of things you might be concerned about in training a model for consumer lending from a responsible AI perspective? So, of course, you have to think about how you're going to train the model and the source of the data that you gathered for this process. And so, in particular, if you have historical data generated by human lending officers and they have some demographic bias in the decisions that they make, you shouldn't expect training a model on that same data to eradicate that bias rather than perpetuate it. And then, of course, if you're worried about these types of fairness or equity issues, you have to, these are computers and models and data after all, you have to figure out a way of basically defining fairness in a way that's satisfying to you and then enforcing it in the trained model. And so a typical definition, for instance, in fairness in a consumer lending application might be equalizing the false rejection rates across different populations. So if you think about the two types of only the two types of mistakes that you can make in such an application, either you deny a loan to a creditworthy person or you give a loan to somebody who's going to default, we might argue, and it's definitely debatable, and there's many, many different definitions of fairness you could adopt, but a reasonable one would be across different demographic groups, perhaps racial groups, gender groups, combinations of them, that you don't want the false rejection rate, the rate at which you are denying creditworthy applicants, to be wildly different between different racial groups, different gender groups, or the like. And we know quite a bit these days about how to train models to enforce those kinds of constraints. So instead of solving the normal optimization problem, which is just minimize the error on the data in front of you, period, you instead solve the problem, minimize the error on the data in front of you, subject to the constraints that the false rejection rate not vary considerably across different groups, okay? And there's a lot to say about this, and there's a lot that's been written about it in the last 10 or so years. And so the fact that we have this very, very targeted use case and a model that's really only making one kind of prediction and has very prescribed outputs rather than open-ended outputs basically gives us a handle, some leverage on solving this problem from an underlying scientific and technical perspective. So now I want you to engage in the thought experiment of what would the analogous thing be for a large language model? What would it mean, for instance, concretely, for a large language model to be fair or give approximately equal treatment across different demographic groups in a large language model? And I want to try to convince you that this is a much, much more difficult problem. And it's a much more difficult problem that we wish was a technical problem at this point, but it's even more of a definitional problem than anything else. And so I might give the example of gender bias, let's say, in the completion or selection of pronouns in the continuation of a prompt. So imagine that I go to a large language model and I type in some prompt like, Dr. Hansen studied the patient's chart carefully and then, and you might expect the continuation in referring to Dr. Hansen to assign, let's say, either male or female pronouns to a Dr. Hansen. If you tried this on large language models that were available a few years ago, you would invariably get male pronoun completions from a prompt that involved a reference to Dr. Hansen. And so one thing I might ask for in a large language model is that it not do that kind of thing. If some kind of occupation is mentioned, that the frequency of continuations should approximately equally respond with male and female and perhaps other pronouns as well. But it's much more nuanced than that because there might have been things in the prompt that would change the distribution that I want over the selection of pronouns, for instance. And of course, this isn't just applicable to doctors, but we might want to enforce the same kind of equity across many, many different, every occupation you can imagine, like firefighters, nurses, accountants, lawyers, what have you. But then if I say, for instance, that Dr. Hansen has a beard, then do we still want to complete with male and female pronouns with equal frequency? Perhaps not. What if instead of mentioning a Dr. Hansen, the prompt mentions a WNBA player, the Women's National Basketball Association? Do we want that to complete 50% of the time or with some frequency of male pronouns? And I'm belaboring this for a minute just to point out how like this, even just figuring out what we mean by fairness for this particular problem of pronoun selection in the completion of a prompt where some occupation is mentioned is very, very difficult to articulate. And there's too many, conditions that could change what we want the distribution to be, and there's too many occupations. And so this is very much a work in progress, and people are thinking about sort of more general ways of measuring and then enforcing fairness, the same way that we have a good handle on the science for things like consumer lending, or more generally very prescribed point-wise predictions. And so the overall message here is that you can see that even just defining what fairness might mean, forget about how you would enforce it technically in the context of large language models, requires new approaches and solutions. The science that we had on these topics up until recently will not suffice and doesn't obviously generalize to cases like this where the output is much more open-ended. And similarly, things like privacy concerns have morphed in the generative era. So what might privacy concerns be in the case of traditional AI or machine learning like consumer lending? Well, I might want the property that the trained model doesn't let a third party exfiltrate or reverse engineer financial information. So if your loan application was part of the training data, you don't want somebody who can play with the input-output behavior of the trained model to actually be able to figure out what your loan application looked like. Unless you think that this is kind of an abstract, unlikely concern, it's quite often that any predictive model that's making a binary prediction, like the example I'm giving, will accompany that prediction with a confidence value. It'll say like, well, I think this person will repay the loan, and I am 70% confidence. If by playing with the input-output behavior of the model, you can find an input in which the model expresses 100% confidence, that's almost certainly because that record was in the training data already, and the model already knew what the outcome of the loan was, okay? And so again, these problems persist in the generative era, but they become much more nuanced, including in ways I'll mention in a few minutes. But one of them is just the literal regurgitation of training data, right? You type in something like Michael Kearns' address is, and you don't want the LLM, even if my home address happened to be in the training data, you don't want the model to regurgitate the output verbatim. But now, because the output is so open-ended, you have the additional concern that like, well, it didn't output my home address verbatim, but it had output some variant of it that's sufficiently close that with a little bit of work, anybody could figure out what it actually was. And so the high-level point here is that the generative AI era has not only made traditional responsible AI dimensions and concerns exacerbated, but it's introduced entirely new ones as well, and I'm going to spend a little bit of time talking about each of these. But they include things that you've probably all read about in the mainstream media or elsewhere, things like concerns around veracity, like hallucinations, the output of the LLM just making up apparently factual information, which is in fact verifiably false. There's concerns, of course, around toxicity of output. If my model is outputting 0 or 1, I might not like the prediction it's making, but it's unlikely that I'm going to call it toxic or offensive or disturbing. There are concerns, privacy concerns that are starting to bleed into intellectual property concerns, and this is a topic I'll mention a little bit later, but that also, of course, touches on the fact that our legal policy and regulatory framework for thinking about things like privacy or copyright even didn't anticipate the training of these models on, artistic data or creative writing or the like, and stylistic appropriation, for example. And the same goes for things like more traditional forms of data privacy. So let me talk about hallucinations for a second. I'm betting that all of you are familiar with the concept and may have in fact experienced hallucinations in your playing around with various LLMs. I don't know how well you can read this, but basically the prompt here to the LLM asks it to tell us about some papers by me, Michael Kearns. And let me get here to where I can read it. It starts off by saying, oh, Michael Kearns is a prominent computer scientist. Thank you very much. It then correctly names several areas in which I am a researcher. And then it lists a bunch of papers. Interestingly, it seems to mainly have picked up on my alter ego in game theory rather than machine learning, but that's probably because once it started generating tokens from the lexicon of game theory, then it continues to do so because that's, sort of reinforced what the context is. But what I could say about these papers, if we went through each one of them, is that 2 of them are entirely fictitious, papers that I never wrote with co-authors that I never wrote, and the papers don't even exist. But they're all plausible, right? And the co-authors actually exist as real people whose names I recognized. 2 of them, none of them are actually entirely correct. 2 of them have true titles, but with co-authors, with different co-authors than the papers I actually wrote with. One of them mentions Ken Arrow as a co-author. He's the late Nobel Prize winning economist. I wish I wrote a paper with Ken Arrow, but I didn't. But this is what we mean by hallucination. And if you understand how an LLM works, it's not hard to see why this happens, because you're not actually going out and looking up citations. You are just generating words from the lexicon associated with whatever my footprint in the training data was at the time of the training of the model, okay? Let's go on to talk about toxicity and safety for a second. And again, what I'm trying to do with my time here is just not point out to you sort of what the solutions are, which people like me are actively thinking about, but just what some of the nuances are, and even figuring out what you want to enforce. So for instance, toxicity and safety. So, there are many passages that are quotations from famous writings and novels. If an LLM outputs a quotation that might be considered offensive by some or even many, but it clearly identifies it as a quote from a well-known, text, do we want to suppress that? I mean, it depends on the context, probably. It depends on who's reading it. We wouldn't want to put it in front of children, but we wouldn't want a blanket suppression of it because that might amount to a form of censorship, okay? What about, in a similar vein, what about people's opinions that others might find distasteful but are clearly marked as the opinions of that individual? And so I think one of the things that Peter and I have realized over time in the generative era is that, we need to find some middle ground between the generality of things like large language models and enough specificity in use cases that we can start to imagine what the constraints might look like. So what do I mean by that? Well, what I mean by that is if I'm using a large language model as a creative writing aid and I'm writing, novels or short stories for adults, then I might have a certain tolerance for certain amounts of content that people might call toxic, for instance, vulgar language, for instance. If I'm using an LLM as a writing aid for children's book, you have 0 tolerance for that, obviously. And so once you start to say, even within a broader use case like content generation, exactly what the use case is, what the audience is, then you can start to come closer to articulating the constraints that you want to enforce. And ideally, you would like to be able to write them down in almost a mathematical formal language so that you can constrain the training process to obey those constraints. And so, many of you are probably familiar with the fact that a lot of the large language models that we have around today are sort of trying to approach some of these problems with so-called guardrail models. So things like toxicity detectors that are applied both to the prompt and to the output, and that perhaps even have a knob on them that can set your tolerance for how much toxicity you want, what types of toxicity you want, because of course, if you look at the literature on toxicity, classification, and detection, it's not just toxic or not toxic, it's what type of toxicity, what type of content. Is it vulgar language? Is it images? Is it other disturbing content, et cetera, and what is the severity of it? Intellectual property is another area that now is front and center in the generative era, because now, of course, we have concerns like this example where we've gone to a image generation model with a text prompt that says, create a painting of a cat in the style of Picasso. And, this is in some strange gray zone between privacy and things like copyright, because the Picasso estate or the Andy Warhol estate, like these images, the original images, they're not private data. They're not like your loan application or my home address. They're in the public domain, and perhaps the artists or writers want them to be in the public domain, but they didn't anticipate them being used to train a model that then is engaged in some kind of perhaps stylistic appropriation. And so again, it's hard to say exactly what we want. In one context, you might call it a hallucination. In another, you might call it a generalization. In one case, you might call it stylistic appropriation. In another case, you might call it sort of, appropriate creativity. And this is, I think, an area that won't have purely technical or scientific solutions, but it'll have to involve our legal system adapting to the unforeseen training of these models and the use of this kind of data. And so let me just conclude by saying, I've told you about a lot of problems, and I've told you about a lot of problems that have gotten harder, not just to solve, but even to conceptualize and sort of define what we want in the generative era. But there is quite a bit of science going on. I mean, I know many people in my field that more or less I would describe as they've stopped doing whatever they've been doing for their entire career to work on responsible AI. And so you have a lot of very, very smart people that are thinking hard about these issues. Some of these things, I think, will have technical solutions, kind of like the fairness constraints I described in consumer lending. Others are going to require a strong public policy, legal, and regulatory framework. But, just to mention not all of these, but things like red teaming or watermarking, sort of watermarking in order to identify content that was generated by an LLM so that people aren't getting fooled by AI-generated content in inappropriate ways. The somewhat distasteful phrase model disgorgement and machine unlearning refers to sort of an emerging science around how do you take a model that's been trained and sort of remove the effects of particular pieces or subsets of the training data on the output of that model, ideally in a way that doesn't require retraining the model from scratch, which, if you know about the size and expense of training these models, is completely infeasible to be doing like on an ongoing basis every time somebody wants their data to be removed from the training process. And so there's a lot going on scientifically, and I want to now turn it over to Peter to talk about how we take all of this science and the challenges that generative AI presents and sort of operationalize it within the context of AWS products and services. So Peter, take it away.
All right, thank you, Michael. So all right, so for a little bit of context, I lead a central team at AWS that advances the science and practice of responsible AI, and that means that we live ambiguities that Michael has been discussing over the past 20 minutes every day of our life. So let me just start with a little bit of level setting, okay, to make sure that everybody's on the same page. I want to observe that ML software is not smart traditional software, okay? There's a couple of fundamental differences from which a lot of stuff flows. First one is that with ML solutions, right, we spec with data as opposed to traditional software where we're speccing with human language, okay? That causes problems right up front. If you're an ML team and you go out and you ask a data team to build you a nice data set, one of the first things they're likely to do is try and deliver very high quality data, which means they give you an extremely detailed sort of set of guidelines for the people building the data set. What that really means is that they tried to write down in English, what the manifold is that they're asking the data team to label, which completely contradicts the point of going to data in the first place because you couldn't write it down in English. If you could, you would have done that, this sort of historical feature engineering. So that's actually a big difference right off the bat. The second one is that with traditional software, right, customers do not expect to test. It should just work right out of the box. With ML solutions, customers must test. This is completely different, all right? As soon as you introduce privacy, that means that it's possible that someone submits data into the system that has assumptions that differ from the assumptions on which it was trained, and only the person submitting the data can know that. So there's a testing expectation. With that testing expectation comes the expectation that you know how to build data sets, you know how to judge the results, et cetera, et cetera. So another big difference. Third one, with traditional ML software, right? With traditional software, when you release version n+1, you expect it to work as well as or better as version n on every single input. Not so with ML solutions. On ML solutions, new releases are going to work better with respect to some metric, for example, the average, which means you can have things stop working for a particular person or a particular input that worked before. And again, you have to have processes in place to handle that. So this doesn't change with Gen AI. All right? So that's kind of the base level of stuff that we have to worry about. And all of that means you have sort of this shared responsibility between providers of models and deployers of models. Okay, so that's a fundamental point. Now on top of that, we layer what we consider sort of considerations or dimensions of responsible AI, and Michael has talked about a number of these, but there are more still. We have, in the age of Gen AI, we have the issue of controllability, right, which is about making sure that you can steer and monitor your model to achieve its desired system behaviors. I think in the worst case, people are wondering or worrying about, some people may be worrying about Skynet and something running amok. Well, do you have control levers, right, that you can employ to steer this thing? And do you have monitoring mechanisms to make sure that, in fact, it's doing what you expect? And we have privacy and security, which Michael talked about, and safety, and fairness, and then veracity and robustness. Those are there. We also have explainability, transparency, governance. All of these are issues that you have to juggle when you're deploying ML solutions. And you need to juggle these kinds of properties of your application, of your model, of your supply chain, on top of those issues about the shared responsibility model. All right, let me just pause. I hope this isn't just raising a lot of concern. It's a lot to juggle. But there is a way forward. We have a framework that we use to think about how we make our investments in this. Obviously, leading it is our investments in science. Then we have a lot of work that we put into translating the science into practice. And then thirdly, we spend time thinking about how we bake all of this into the entire ML DevOps cycle. And then finally, we also think about the people. What stakeholders do we engage? How do we educate people, et cetera? So I'm going to cover, since Michael covered the first box to some extent, I'm going to cover the second, third, and fourth, and try and leave everybody optimistic that, in fact, we can make progress in building and operating responsibly. Okay, so second box, theory to practice. Let's talk about sort of some secrets to success. And I think Michael was highlighting this one in a number of cases, defining application use cases narrowly. And I'm going to dig into each of these to make sure that they're clear. Second one, matching a process, your development process, your operating processes to the level of risk. Third, treating data sets as product specs. Fourth, distinguishing application performance by data set. And five, operationalizing the shared responsibility model. Okay, so these are just 5 things to consider. Let's dig into each of these. So what does it mean to have a narrow application case, all right? A lot of people think, okay, face recognition, that's a use case. It's not. Here are just 3 flavors. Retrieving an image from a gallery could be for you have a found child and you want to look up the child in a gallery of missing children, or it could be some other gallery retrieval. Celebrity recognition, looking up a celebrity in a database of production video. Or it could be a virtual proctoring application, right? But each of these, although they employ face recognition, have different kinds of variation that you have to worry about, different kinds of biases, different consequences for an error, and different ways in which you tune the system so that you have sort of fewer of the errors that are more costly. So for example, with when you're retrieving, images, let's say in the missing child case, right? You really want to return as many matches as you possibly can. But in the context of looking up a celebrity to find a clip in a video, right, you're going to get lots of hits. So there you're not going to tune it for, recall. Now, in the Gen AI case, you have the same kind of sets of issues. Suppose that you want to catalog a product versus persuading to buy. You would write different things if you're a human, right, than you would, if someone just says, well, in general, write some words about a product. So when you're cataloging a product, you are probably intending there to be sort of a broad demographic. Anybody can read the catalog. You want to worry about veracity. You have the consequences, brand damage, lost sales, returns. When tuning it, you're going to favor neutrality of the language, clarity, completeness. But when you try and persuade someone to buy, you're probably going to target a narrow demographic. You're going to have additional issues with unwanted bias. I mean, how is the LLM thinking about this demographic? You have greater consequences if it shows unwanted bias in terms of representative harm, for example. And when you tune it, you're probably going to try and tune it to sort of zero in not on a complete description of the product, but on the sort of the particular problem that this demographic is most interested in and the benefit to that demographic. So it's the same thing. Traditional AI, generative AI, zoom in on a narrow use case. And I just can't emphasize this enough, because if you go broad, you're going to get into trouble. You're not going to be able to define what bias really means. You're going to end up doing worst case risk analyses, which tell you not to do it. So this is absolutely critical as a first step. Second thing, risk-based approach, okay? If your application is recommending music versus, say, identifying a tumor, it's very clearly like different consequences for getting this wrong. All right, so you need to have a systematic approach to assessing risk within the organization. First piece of advice is to align with the NIST framework. Second thing is to realize that in some contexts, risk, people worry about risk to their own organization, but in this situation, we're worrying about risk to the stakeholders, okay? It's not about saving your bacon, it's about saving their bacon, all right? So you want to identify all the stakeholders, both in the development process, imagine the people who are labeling stuff for toxicity, and on the usage side, and people who, might not be included in the process of building it. As you know, many LLMs just focus on English, right? And there's reasons for that, but nonetheless, that means that there are groups which are not being served as well as those things. So go through, identify the stakeholders, identify potential events, negative or positive, estimate likelihood and impact of each event, aggregate the risks, and then choose development and operating processes that are appropriate to the level of risk. Okay? This is really not easy to do. Like, you can get in, very extended arguments with people on what the actual likelihood and impact of a particular event is, right? It takes sort of a social process of forming, storming, norming, performing before you get everybody able to consistently assess risk. But it's critical. Then treating data sets as specs, okay? We said before, data sets are particularly key here. So take a look at what's actually in the input. Anticipate global diversity. So for example, to pull on the traditional AI example of doing face recognition, right? You may be familiar with people talking about skin tone in terms of having 5, maybe 10 variations, but the actual curve, if you go and look at it, is this sort of banana-shaped curve in RGB space. It's much more complicated, and you want to sort of accommodate the full diversity that's out there. You have to think about the difference between intrinsic and confounding variation, make sure your data sets have it, and use lots of different data sets. Gen AI, it's going to turn out to be the same thing. Your data set is encoding your design policies, all right? Distinguishing application performance by data set. This is also absolutely critical to internalize. Performance is a function of an application and a data set, not just the application. And I know this goes against everything people want. They want to say this model is good, or this model is bad, or this model works, or this model doesn't work. And that's really just not the way to think about it. The issue is, how well does a model or application perform on a particular data set? So, what we might imagine, right, is that over time, model performance increases as you rev the model and get better, right, against a particular test data set A, right? But there might be some other test data set B on which it does even better over time. Or there might be some test data set C on which it gets progressively worse over time. All right, all of these are possibilities. But what this really means is that when you're developing, okay, both in the trad space and in Gen AI, okay, you've got to worry about two development trajectories, the trajectory of the model and the trajectory of the data set. Because very often people are evolving the data set. It's not constant. And every time you evolve the data set, you're jumping the data set from A to C or A to B or something like that. Okay? So another critical point in terms of doing this practically. Now, in terms of sharing responsibility upstream and downstream, if you want to operationalize that, okay, lots of things to do. You have to think ahead. All right? If you're a model provider, as, for example, Amazon is with its Titan family, right? You need to anticipate downstream use cases. If you're downstream, you need to define your application use cases narrowly. But upstream, it's even harder, right? When you anticipate diverse downstream use cases, you still have to sort of treat them narrowly and say, these are going to be some things that you really shouldn't do, and these are going to be some things that you really are, that we're really designing for. You've got to on both sides, assess risk and select the process. On both sides, you're building data sets. Upstream, you're building data sets to train and evaluate. Downstream, you may not be building, but you still need to evaluate. So you still have to build data sets. Testing the component on anticipated data. Downstream, testing end-to-end. Just because a particular LLM or foundation model has been tested, out the wazoo by lots of folks, doesn't mean that you can assume, therefore, that you can just drop it into an application and you're okay. You should test your application end-to-end and make sure this whole thing is really working as you expect. Okay, sending feedback. If, for example, we're using a vendor to help us build a data set, okay, and we learn something, we're going to give them feedback. Similarly, if someone, downstream deploys an Amazon service and has an issue, they got to let us know. The communication has to go, upstream and downstream. And then you also have to act on what you've learned, right? That's absolutely critical. So think about if you're going to be deploying, Gen AI within your organization, either internally or you're building products based upon it. Think about having processes in place to deal with each of these issues. So one example of the way in which we do this is that we've introduced last year these things we call AWS AI service cards. They describe services from the point of view of not a scientist or an engineer. We have model cards and data sheets for things like that. These are trying to educate sort of a more non-technical audience about appropriate usage of a particular service. So anyway, just one example. All right, so let's move to the third box where we talked about, first we talked about theory to practice. Then we talk about, okay, well, we know what good practices are. We have a set of good practices. How do we kind of embed those throughout the entire ML DevOps cycle, right? So here's a cartoon of the DevOps cycle. Everyone has probably a different favorite cartoon. This is just one of them. And the question is like, where do we think about these issues? And the answer is going to be, as you probably can expect, absolutely everywhere, right? Every single stage, you got to sit down and think about how does controllability, fairness, privacy, security, robustness, how do all of those issues play out in this particular, block of the cycle? Let me just pick one example, which is at the very beginning, if I can go back here, right? We had a ML problem formulation box over on the left-hand side there. Okay, so a fundamental question is just asking whether or not ML is appropriate. All right, so how well do humans perform on the same tasks? What tasks are humans really solving? Right? Might your system be repurposed? You just kind of ask the big questions. Give yourself space and time to do this. Let me give you a few examples. We have had people ask, can you build a loitering detector, for example? Loitering is say in the context of you have video, sort of security video of your store, and you want to know if someone is loitering, so your security team can take some action. Okay, well, loitering is a value judgment. You don't want the system making value judgments. How is it going to do that? You cannot. That's not a good system to be thinking about building. All right. Can you do sort of a number of humans standing in some location for a certain time period? Yes. All right. That's much more practical. All right. Stylish clothing 2 years out. Could you predict that? Well, what are your input signals going to be? I would say this is kind of a question mark. Try it, but good luck. This one, write ad copy for a group for a red and blue 64-inch diameter golf umbrella. All right? So in general, can you write persuasive ad copy? Well, maybe you can if you use demographic groups that are defined by the task that a particular person cares about. But maybe you're going to get into a lot of trouble with LLMs if you try and use kind of standard definitions of demographic groups that represent intersections of gender, age, and ethnicity or something like that, because maybe the LLM hasn't really, and how could it code what the biases of those folks might be. So anyway, ask those questions. And here I think, if you reflect upon this, I think it's also good to appreciate that you have a very powerful tool in deciding what your system will do and what it won't do. You do not have to build a system, for example, that handles the full diversity of the planet in every possible situation. If you had to do that every time, you would probably never get off the ground. How would you get all the data that you needed, et cetera, et cetera? It would be enormously expensive, and you might build something that eventually people didn't even want, and you have to learn that. So you have this lever, which is transparency. You can elect to say to folks, okay, these are the circumstances in which it's intended to be used, and this is how it works. And everything else is kind of, either unknown or at risk, and please don't do it. Or do it with full knowledge that you're going to have to do extra testing, okay? So, you have this lever that you can choose to operate. All right. So across the ML lifecycle, we have a number of things that we deploy. I think the primary thing to make everyone aware of is people. We have a partner network. We have a Gen AI Innovation Center. We have solution architects. There's a lot of complexity, as Michael was pointing out, and as I have sort of taken you through a bit up to this point. And so those folks can be extremely helpful. We also have tools. On SageMaker, we have Data Wrangler, we have Ground Truth, we have Clarify, we have Model Monitor, we have ML governance tools, for example, model cards. And we have the internal team that focuses on helping all of our service advance the science and practice of responsible AI. So we have a lot of investment on this. And the outputs you can see in services like Amazon Code Whisperer, Amazon Titan. Right on the Code Whisperer side, we have data that's private and secure. We have content filtering. We have built-in security scanning. We have attribution for sourcing. We have indemnification. We have on the Titan side, we have, again, privacy, security, content filtering. We have human alignment through reinforcement learning and through supervised fine-tuning. We have knowledge enhancement via RAG, orchestration, customization. So there's lots of investment going into these, all using the principles that we've talked about previously. All right, so let me finally switch to the bucket around people. I have sort of walked through a lot of challenges. And if you're in an organization which is either trying to deploy a Gen AI application internally or build one for its own customers, right, there's going to be some process that you go through of building awareness, sort of establishing foundational skills, seeing capabilities emerge, and then sort of finally baking it into your operations. And you have to just sort of set upon this journey explicitly, okay? And as you go down this journey, you can't just expect it to happen without, thinking it through. I think one of the things I want to call out is that responsible AI is not something purely for your technical teams, for your scientists and for your engineers. It's absolutely crucial that your product managers be in the center of this, okay? So, at Amazon, we have this kind of tier where, foundational principles around human rights and sustainability are things that, we pursue across the company. And then we have, on top of that, the set of normal stuff that any product manager is worrying about: use case accuracy, feature set, latency, cost, uptime. And then on top of that, you have all the RAI things that we were worrying about, right? And so you're going to inevitably find yourself, in some situation where, the things on the bottom are things you cannot trade off. The things in the middle are things that people are trading off today in the normal course of business. Do I want this many features that's going to come at a higher cost? If I lower the features, lower cost, that kind of thing. And then the RAI properties are also going to have potential trade-offs, all right? And those need to be made explicit. And again, if you happen to have gone down the path of having narrow use cases, it's much easier to understand what those trade-offs are and to communicate them so that people can have a good experience using it. And then the last thing, I know it may sound a little much, but participate. In other words, you're in your org, you're trying to develop your capabilities within your org, but there's a lot of activity on the policy side, on the legislative side, on the regulatory side, and you need to participate as much as you can in those processes. ISO 42001 is going to be a linchpin of the EU AI Act. Right? But there's 30 other standards, roughly, that are also in development, okay? And the folks developing these standards are trying to do the best that they can, but the more input they have from people who are actually building and deploying applications, the more likely these standards will actually be effective. All right, so that's, for example, why we participated in the White House voluntary commitments. We participate on lots of standard bodies, but we would encourage everyone else to do the same. So okay, if you want further information, all right, we have a couple of, actually we have three, not two, pointers for you. One, you can hear more from Michael at the first link. The second one, you can learn more about the White House commitments. And the third one gives you more information on getting started with Gen AI with our services. All right, so I want to thank you at this point. We've got about 11 minutes left.